Okay, welcome to lecture number 4 for Signals and Systems. In last lecture, we discussed about periodic and aperiodic signals. We said that if a signal repeats itself in same pattern over a certain period of time, repeat itself again and again, then we can say that signal is a periodic signal. Otherwise, if a signal do not repeat its shape, then we can say that that signal is a aperiodic signal. So we also discussed about even and odd signal. We said that if a signal repeat itself, or we can say if a signal has a mirror image on with respect to y-axis, we say that that image is a even signal, and if signal is anti-symmetric with respect to y-axis, then we can say that signal is a odd signal. To take the condition for even signal, we just compare values of x of t and x of minus t. If both values are equal, then we say that the signal is even. And to check for the stability, to check whether signal is odd or not, we just what we do, we just compare x of minus t is equal to minus x of t. If both values are same, we say both functions yield same result, then we can say that the signal is odd. And we concluded that if a signal can be either even or odd or neither even nor odd, but any signal in this world that exists can be decomposed into its even and odd part. So afterwards we discussed about periodicity of cosine waves, especially in discrete time systems. We said that in discrete time signals, if a signal is periodic, it has the time period which is a rational number. If its time period is not a rational number, then we cannot say signal is periodic. If a signal, in order to check the condition of periodicity, what we do, we just divide its angular frequency with 2 pi. 2 pi divided by angular frequency, and if it yields a rational number, then we can say signal sinusoidal signal is periodic. Otherwise, it is not periodic. But continuous time signals are always periodic with respect to 2 pi by omega naught. Okay, so in today's class, we will mainly focus on unit step, unit impulse, and we will go through basic definition of system and its properties. Okay, so I want to get rid of this thing. Okay, so everything is clear from last lecture. Is it audible?
Yes, sir.
Okay, so in today's class we will talk about unit step function as signal. It is very important with respect to signal and system. We will talk about it, and unit impulse. So without wasting our time, let's start. So what is a unit step function or unit step signal? Only for we are talking about discrete, because you can see here is n index and square brackets. So we already discussed about it, that if we see n axis and square brackets, so we can say that this signal is a discrete time signal. We are talking about a discrete time signal. So a unit step signal is always denoted by u square bracket, then you can write k or n depend upon the book that you follow. Normally it is written as u of n, and it is 1, its amplitude is 1 from 0 onwards up to nth sample. It is always 1. There is no change in amplitude from 0 to, you can say, infinity. So on negative axis it is always 0. So it is very easy to define a discrete unit step signal, but we will talk about continuous time and we will see what are complications there. But as far as discrete time unit step function is concerned, it is very simple. You can just denote it by u of n, and it is 1 for n greater than or equal to 0. So means from 0 index onwards up to infinity, the output of the signal is always 1. Okay. In contrast to that, we have another signal that is called unit impulse function. Okay, it is only defined on zeroth. We can say it's always defined on origin. So you can see on 0 index its value is 1. In negative axis it is always 0. On positive axis it is always 0. It is always defined on delta of 0. Okay, it is defined by, it is denoted by delta function. So it always yield output only at delta of 0. Is it easy to understand?
Yes, sir.
So
Yes, sir.
these are two basic functions, unit step signal and unit impulse signal. Sometimes people write function as well, because a signal is always a function. Okay, so moving further, now we can always drive one signal from other. We can drive unit impulse function from unit step function and unit step function from unit impulse function as well. So if you see this slide, we can also, as you see, we have delta of n is equal to u of n minus u of n minus 1. Now just focus on this signal, u of n minus 1. Now we talked about different proper transformation on independent variable, right? We talked about shifting, we talked about scaling, we talked about time reversal. Now which property is applied here? Can anybody tell me? 10.
Yes, sir.
U of n minus 1. Which property is used here? Which transformation is done here? It is time reversal.
Yes, sir. Time reversal, sir.
For
Time shifted.
only time shifting, right? Because we have n, there is no negative sign with n. It is only shifted signal. How many units? U of n minus 1. How many units must it be shifted?
1.
1 only. So on left or right?
So
It must.
delay.
It is a delay. Yes, 1 unit delay. So you can see that normally a unit step u of n starts from 0 up to n, but now this particular part is 1 unit delayed. So I have drawn here u of n minus 1. You can see the sample which arrived at 1 is now arriving at 0. I'm sorry, the sample which arrived at 0, now it is arriving on first index. So it's 1 unit delay. Okay, now the next operation is we have to subtract this driven signal from the original signal. Now if you subtract 1 minus 0, what would you get? 1. And we have up to infinity the amplitude of both signal 1. So 1 minus 1 is always 0. So we got unit impulse from unit step function. Is it clear? Is it clear?
Yes, sir.
Okay. So
Yes, sir.
Yes, sir.
okay, coming to next slide. Now we have derived unit impulse from unit step, but can we derive unit step from unit impulse? So if you see this equation, u of n is equal to summation k from 0 to infinity delta n minus k. Now we just solve it for u of 0. So what must be u of 0? U of 0 must be equal to summation k from 0 to infinity delta 0 minus k, right? Okay. If you solve it, if you solve this summation, you would get delta of 0 plus delta of minus 1 plus delta of minus 2 up to delta of infinity. And we know that delta is always defined on only index 0. So u of 0 must be only getting value, what value it must get? It must only get 1. Can you understand why? 4 5.
सर स्क्रीन शो नहीं हो रही है